Coming up on today's show, we're going to talk about one thing that you can do to unlock more of your equipment's uptime and productivity than just about anything else that I could possibly imagine. Curious to know what that is? Well, stick around and find out. Hey, thanks for joining me today. I'm your friend Kurt Stahle, that plastics guy, and I really appreciate you being here. If you're new to the show, this is where I share my 4 decades of plastics industry experience with you. I'll educate, interview, share case studies, showcase innovative products, and always discuss the topics and trends that affect our industry. Today's podcast is sponsored by, coincidentally, Fresh Start Polymer Solutions, manufacturers of Fresh Start Purge compounds, which are safe for all types of resins and processing equipment. We offer mechanical and chemical-mechanical hybrid formulations. They're fast with no soak time, effective and hot runner systems. Nothing buys you more uptime, spoiler alert, than using Fresh Start to stream your workflow. Fresh Start products are sold across Canada by my company, Simcoe Plastics Limited, where we truly have a passion for polymers. You can visit us at simcoeplastics.com or contact us at info@simcoeplastics.com. So, did I just give it away? Well, quite possibly. In my opinion, and this is backed up by decades of working on the shop floor, calling on customers, being in the industry and hearing all the stories, the thing that you can do to get the most out of your capital equipment, your processing equipment on your shop floor, is to ensure that material and color transitions happen as smoothly as you possibly can make them happen. And how do you do that? Well, a good purging compound goes an awful long way to make that happen. Now, since you're going to be listening to this, fingers crossed, on a Monday, a few days ago on Friday, which sounds very weird because I'm recording this on a Thursday, but I did a Tech Tip Friday that talked about purging compound and making purging compound an absolute must on your shop floor if you want to unlock that maximum uptime on your equipment. So when I got my start in the injection molding industry, courtesy the family business, one of the things that we really struggled with until we put a proper system in place was just simply having the right tools for the guys to do, and I'm saying guys because that's what it was back then, for the guys to do mold changes. And they could spend an inordinate amount of time walking to and from the workshop area in the molding facility out to one of the machines to get a tool. Well, we decided to create tool carts, and that eliminated that waste of time. And what was really cool about it, we could cut down mold change times. In some cases, it was an hour or more. And this is simply by someone walking back and forth from a machine to the tool area, the workshop, to get something come back. And of course, they would more than likely be interrupted by 2 or 3 other people who need help, adjusting a parameter on a machine or doing something else. So how do you keep somebody focused? You give them the tools to do the job, and you shorten that downtime on your machine. So if you're faced with an 8-hour shift and a mold change is taking 2.5 or 3 hours, you do the math. I mean, that's about a third of your day gone with your machine not producing parts. No one would allow that to happen on an ongoing basis. And back then we changed it. We put the tools in the hands of the people that needed it to ensure they could do the mold change quickly. Well, fair enough. So once you actually physically change a mold out, you've got to deal with either changing a material, like a material type, maybe going from ABS to a polypro or to a nylon or to a polycarbonate or to acetal, whatever the case, or you're changing a color. We had one customer in particular, this is going back to my early days in molding, where they had a series of tools and we had to run them not only in different materials, but multiple colors within each material family that we ran. Now, Certain things you can do in scheduling your production, running from lightest to darkest, that can certainly save time. And if you're within a common material family, maybe that works and you don't necessarily have to purge. Maybe you can get saleable parts off in a dozen shots or less. And if you're at that threshold, maybe 6 to 10 shots or a dozen shots, as I just said, where you don't have to do anything special, you just walk from one color into the next, maybe a purging compound isn't right in that instance. But how many people actually run jobs in their shop like that? I don't think it's that many. I'm thinking in terms of one story that heard, and I can't name names on this, but a very significant toy manufacturer that did up to about 85 color changes a day on their shop floor, not just in one machine. You can't possibly be sequencing everything in the most logical color choice to get through a workday without doing any purging. You just can't possibly anticipate. Now, think about, too, in the automotive sector, you try to set your production up where you're running in that logical sequence of colors, but really you're making product based on the releases you get from your customer. And are they necessarily going to put everything together nice and tight that you can run from a light beige to a black over 3 or 4 colors every single time? No, it just doesn't work like that. Sometimes it does, and sometimes you'll make the call as the molder to set up your production so you can get the right sequence of colors and minimize downtime that way. But what if you just can't? How much time are you willing to tolerate with a machine down before you reach for a commercial purging compound? Well, if your machine's going to be down, if you're thinking it's an hour or hour and a half, you really owe it to yourself to examine the implementation of a commercial purging compound and a protocol to handle that transition from color or material type to the next. And, half hour, hour, if you're in that time frame, and if you think it's only a half an hour, I'll guarantee you, your folks on the shop floor are going to face distractions with other machines, and it could easily swell out to an hour or more. I've seen it multiple times, going into customer locations, waiting for a mold trial. You just observe things. And the setup technicians, they're not lazy. They're not incapable of doing their job. They're pulled in multiple directions at once. It's sort of the flow in a very dynamic shop floor setting. It's tough to stay focused on one thing. So if you're at a certain window of time where you're going to have a cutover in either color or material, and you think maybe half an hour or more, you want to run a purging compound. Absolutely. If you think you can do it within a few shots, maybe the economics aren't there. So if you've reached that decision where you want to bring a commercial purging compound into your facility, well, what are the criteria? How do you want to assess these things? Do you just buy the cheapest? Well, if you've been paying attention to my Tech Tip Fridays, I did one about a week and a half ago where I talked about the perils of just buying the cheapest material. Because, in plastic, we buy by density and we sell parts that are volumetric, and an expensive material with a lower specific gravity can give you, in fact, a cheaper part than one with a cheaper material with a higher density. Again, you buy by the pound or kilo and you sell volumetrically. I'd like to encourage you to consider some, I'm not going to call it unorthodox, but it's perhaps not the most obvious math. If you have a purging compound comparison, 2 or 3 different grades, and you have a cheap product and you've got a product that's maybe, 20, 30 cents a pound more, or even a little bit more, depending on the volumes and contract that's presented to you, but more money. Does the one that's more money, does that represent worse value or better value? Well, what if you could cut your purging time to 1/10? You heard that right. 1/10 of what a cheap compound could do. All of a sudden, you have maybe more cost per pound in the purge. You're wasting less time, energy. Your equipment is up quicker. and you've got packable parts quicker. So that cost per pound, we'll call it a quote unquote premium for the better, more advanced product, all of a sudden translates into a significant increase in your uptime versus that less expensive budget brand of Purge compound. So I encourage you to evaluate this type of technology through a few lenses. The idea that you could just run prime material through and purge your machine out, I really challenge you on that. It's not the most efficient use of your prime material, which, let's face it, there are price cycles where it's going to be a little bit more expensive, a little bit less expensive, but you're wasting prime material. That's material that you could be using to make saleable parts to your customer where the real value is. Okay, so don't waste your most valuable resources, even if you think it's cheap. If you're interested in exploring the math behind calculating the advantages of a purging compound, reach out to me and I can provide a framework for you or do a trial with the product that I sell, the Fresh Start product, and I can help you work through the math as to which purging compound makes sense for you. And I'm pretty sure the product that I can offer is going to compare very favorably. And I can say that after years of selling it and years of other people selling it. So we know it's a high quality product. But unless you actually lay out the math in a very clear and concise manner, you may not really fully understand or appreciate the impact of this particular purging compound and the overall procedure of purging can have on your bottom line and your machine uptime. In many cases, and again, this is something that I think we've all seen in the industry once you're in it for long enough, you can only fit so many machines in a plant. Sometimes there's constraints due to actual physical limitations of building versus the machine size. And sometimes there are restrictions in the electrical feed to the building. You can only get so many amps. So again, this sort of brings the argument back to how do you squeeze the most out of the equipment that you have? You're doing your planned maintenance. You've got spare parts, key spare parts for your machinery, or you've got a dealer who is very close by that has an extensive spare part inventory at their facility with qualified technicians that can come out and look after things. I mean, you can't have equipment down for days or weeks, right? Makes sense. You can't make money when your machines aren't making money. So I really want you to think of the whole idea of a purging process with a good purging compound as another key to maximizing your uptime. And I'll guarantee you, if you look at the leading automotive injection molders and blow molders, plastics processors, they have some form of purging protocol in place. I'll guarantee it. Especially if they are doing anything with colors. I can't go into too many details because of privacy and respecting customers. I can't really tell you, hey, plant X does this. I'd love to share some stories, but I could tell you with one facility that my team was involved in, they were running polycarbonate and switching to a TPO. And it's an unfortunate thing, but there were some constraints around press size. And in that particular instance, without purging compound, they were disassembling the screw, like pulling the screw from the barrel to clean everything by hand. Ouch. That was about 3 days. With purging, and specifically the Fresh Start product, they were into packable parts in under 20 minutes. Maybe 22 or 23, but still. How else do you buy uptime of that magnitude without adding extra equipment on the shop floor? You can't. You're wringing out every single last drop from what you have. So again, I'm going to keep coming back to challenging you on that. So when we look at purging compounds, typically they fall into two major classifications, a mechanical and a chemical. So in a mechanical purge compound, the gist of it is you've got some type of abrasive material in the purge compound. When it's run through the screw and barrel, that abrasive will scour all the surfaces it touches and take the carbon deposits, take the color, take everything out as you move this material, the purging compound, through the screw and barrel and out through the nozzle. Okay, fair enough. On a chemical purging compound, how do I say this? There can be additives that are not strictly mechanical in nature, maybe something that will cause a bubbling to occur, and that acts as the de facto scouring without introducing a mechanical abrasive. So there's some advantages and disadvantages with those. Disadvantages, they typically require a soak time to activate the ingredients that will cause the air, the bubbling, to be made. So not necessarily the quickest. Without some type of mechanical agitation, well, guess what? You're not going to pull everything through that you can. It's not the most effective. I'm not sure actually what products a strictly chemical purging compound would work best on. I do understand that it works a little bit better when it comes to blow molding machines where you have an accumulation pot prior to actually making your shot. But I think for most conventional, for most cyclical or inline processes like conventional injection molding or profile extrusion, I do not believe there's a significant advantage to a chemical-only purging compound. The idea of having the mechanical where you have some abrasive in there to clean everything out, great. That's fantastic. That's the best way to go. Now, the question is, and I'm not going to get too much into this because we've got some really cool technology around the Fresh Start. We have a slightly different take on what constitutes a mechanical abrasive. Our product has been developed to be 100% safe in all machinery, including hot runners, hot tips. You can even injection mold a part with this if you wish. There is nothing damaging in our product. And yet we have that ethos of it being a mechanical product with something to remove the carbon buildups and the color and whatnot. It's just a slightly different approach to it, and I think it's a super cool product as a result. It's a little bit of outside the box thinking, but we are safe in all pieces of equipment and in hot runners, hot tips, and like I said, you could actually even injection mold a part with it if you wish. Not every product behaves in that manner. So that's just something to keep in mind. So if you have an operator who is perhaps new to this process, and rather than purging out everything from the screw and barrel after the job is done, they fire the machine up, they cycle it into auto, and it actually makes a part. Hey, no problem. It's okay. Nothing is going to get damaged with our mechanical product, the MC2HH. I think at this time, I'd also like to add, if you are using a chemical purging compound, please check with your manufacturer to ensure that it's safe with all resin types, as certain products may have a bad reaction with certain resins. And I'm not going to get into specifics because I can't speak for everybody's product, but consult with your supplier to ensure that your purge compound is safe with the products you're using. If it's not, or there's some exclusions, make sure everyone on your shop floor knows it, put it in your work instructions, label the boxes of purge, whatever you have to do to ensure there isn't an accident. But it's just something to keep in mind. So aside from color and material transitions, there are a couple of other instances where you may want to consider an extended purge session. And one of them would be for regular maintenance. If you're going to do a planned maintenance on the tool or perhaps on other aspects of your machinery, you may be well advised to actually do an extra long purging process on the screw and barrel of your machine. Maybe it's once a month, maybe it's quarterly, maybe after running one or two jobs of a certain variety, there's going to be a little extra buildup in there of colorants or carbon, whatever the case. Plan it in. Plan that purging process in in advance so everyone knows that's part of the work instructions for either that particular job or sequence of jobs, or as part of your monthly or bi-monthly planned maintenance. And really, it's just a good practice to do. You may find that you can't have the time every time to do a proper purge when you're in the throes of regular daily production, but you got to do it once a week. Well, that's fine. Build in your time there. The other instance where you may want to consider a prolonged purge is when the equipment is going to be shut down for a long period of time, be it over the holidays or maybe a summer vacation. You pick your length of time and how your shop floor is scheduled. But if you're going to be down for a prolonged period of time, you may want to consider running a safe purge through your equipment and then shutting the equipment down. And there are some reasons for it. If you look at again, the Purge compound that I sell, the Fresh Start, it's based in a very, very safe polyethylene resin. You can't get much safer than that. I can't speak to what other companies use for their carrier resin, but polyethylene, super safe. Put it through your machine. You can shut your machine down, and you won't have to worry about maybe a more exotic engineered resin or something that's a little bit more susceptible to burning under prolonged temperature. You just aren't going to have that concern. So it's kind of a nice thing. It's sometimes referred to as colloquially a weekender, but I think you get the idea. Leave a purge compound in that's safe, that isn't going to degrade, evacuate the prime resins that may be suspect to a degradation over time, and you could safely turn your machine down, turn it off rather. And then when you come back in a week or 2 weeks, whatever the situation is in your shop floor, you can bring the heats back up on that machine, and you aren't going to worry at all about an expensive base resin or a sensitive base resin degrading as your machine comes up to temperature. So that's just a strategy. You may want to think about it. You can't possibly, by the way, get everything out of the screw and barrel of your machine. It just doesn't happen. So having a purge compound in to evacuate your prime resin and working with a purge compound to shut down and then come back up, whenever you're ready to come back up, a week or two or a month later, whatever the case, it's kind of a safer approach to it, and you won't have to worry about that excessive carbon buildup. So that's another trick to keep in mind, and I can help you if you're interested in those types of scenarios. So in terms of a podcast format, I don't think I can really cover too much more generically. Now we sort of get into application and machine specific situations and what product to offer and working around a purging protocol for your specific equipment. And that's part of what I do as part of a needs assessment. We'll work with you to develop something that suits your equipment, your tooling, and teach it to your folks, and we can back it up with the paperwork that is required. So really, the takeaway is don't ignore commercial purging compounds. Don't ignore purging as some sort of unnecessary step. If you wish to maximize the uptime of your equipment and maximize the usefulness of your equipment while it's running, you don't want to mold parts with black spots in them and streaks and all sorts of other things. You want maximum uptime on your equipment and maximum yield from the parts that are made from that equipment. And using a commercial purging compound with good work instructions to back it up is one of the best ways, if not the best way, to ensure uptime on your equipment and keep everything running smooth. And with that, we're at the end of yet another episode. Thanks so much for listening. I really, I enjoy having guests on the show, but we can't always do it. So I like to take these opportunities to talk a little bit more in depth about topics that, are relevant. Maybe I'm working on a project that, ties into it, or there's a case study. So thank you for indulging me for, this period of time talking about Purge. Again, I know it's not the sexiest part of the industry, but once you do the basics and you practice them over and over and over again, you get better at them and your shop floor really, really begins to hum. So if you have any questions or comments about today's show, or you're interested in learning more about the purging compound that I offer through my company, reach out to me, info@simcoplastics.com, or on LinkedIn. You can contact me through that plastics guy, or on my personal page as well in LinkedIn, Kurt Stahle. And please consider following that plastics guy on YouTube and Simco Plastics on Facebook and Instagram. And you can subscribe to our newsletter while you're on our website too. We are going to have a newsletter for you for February that's going to cover a bunch of topics. Probably purging is going to be on there as well. I like to get things between Tech Tip Friday and a long format podcast, and then back it up with a newsletter. I think it keeps everything cohesive, and I hope you can really have some meaningful takeaways from these things. So there we are. Thanks again so much for listening, and take care, and let's be good to each other.